Hello everyone. In this video, we will cover the one-year term insurance. We will cover the discrete case. In this video, discrete means the benefit is payable at the end of the year of death. Consider a one-year term insurance. The policy is issued at age X and with death benefit of 1 payable at the end of the year of death. The insurer pays 1 at the end of the policy year if the individual dies within the year, or the insurer pays nothing if the individual survives beyond the 1-year period. Assume the effective annual rate of interest as I and the corresponding present value factor mu equals 1 over 1 plus I. We are going to construct the PMF of the present value of what the insurer pays. The present value is a random variable. Depends on whether the individual dies within the 1-year period or not. If the individual dies within the 1-year period, that is before reaching age X plus 1, that is Kx equals 0, the corresponding probability is Qx, the insurer pays 1, and the present value is nu, or else if the individual survives beyond age X plus 1, Kx greater than or equals 1, the insurer pays nothing. The probability is Px. Here, by convention, we use Z to denote the present value of the benefit of the insurance. If Kx equals 0, Z is equals nu, or else Z equals 0. If Kx is greater than or equals 1, the complete PMF of Z together with this probability. We are interested in the expected value and the variance of Z. Here, the expected value of Z is nu times Qx plus 0 times Px. Simplify it, this is nu times Qx. The standard notation of the expected value of Z here, we have this notation. This corresponds to the APV, the actuarial present value, or the EPV, the expected present value, or the single net premium of a term insurance with death benefit of 1 payable at the end of the year of death. Therefore, we will write this notation in terms of the expected value of Z, which is nu times Qx. All right, let's explain this notation. The big A corresponds that this is an insurance and the benefit is payable at the end of the year of death. And then the bottom right, X colon angle N. The policy is issued to an individual at age X. This is a 1-year term policy. And then the one above the X. This indicated that the individual must die before the policy expires in order to get the death benefit. And then the coefficient. This is the death benefit. All right, get back to the expected value of Z. So we have nu times Qx. And then the variance of Z, we need to get the expected value of Z squared. Here we have u squared times Qx. Plug this in. And then we get the expression for the variance of Z. All right, so get back to the financial mathematics relating the delta and I. We have the relationship e to the power delta. Delta is the force of interest, equals 1 plus I. If we double the force of interest, we have the following expression. And this equals 1 plus 2I plus I squared. The corresponding effective rate of interest at double force of interest is 2i plus I squared. And we have another notation for that. Okay, delta and I are equivalent. Double the force of interest becomes 2 delta. The corresponding effective rate of interest is 2i plus I squared. We denote it as a 2 as a pre-superscript I. An illustration. Okay, suppose I is 0.05. The corresponding value of delta is 0.04879. Double the force of interest, 2 delta. This is the value. And then the corresponding interest rate, I prime. We get I prime equals 0.1025. And we use this notation, the pre-superscript 2, I equals 0.1025. The pre-superscript 2 corresponds, this expression is evaluated at the double force of interest. All right, so we have the relationship e to the power minus delta equals nu. And the nu square is e to the power minus 2 delta. We express the expectation of z and z square with delta. We have these two expressions. And then you can see the similarity of these two expressions, one with delta and one with 2 delta, the doubled force of interest. And here we use this notation to denote the expected value of z squared. Again, the pre-superscript 2 corresponds to the notation here is evaluated at a double force of interest. All right, so we have the variance of z equals this. Okay, recall the notation. This is the actuarial present value of a 1-year term insurance evaluated at a doubled force of interest. And this is the notation. Let's take a look at an example. Given that Q30 is 0.004 and I is 0.05, find the variance of the present value random variable of a 1-year term insurance issued to an individual at age 30 with death benefit of $1 payable at the end of the year of death. The present value, z, equals nu if kx is 0, or else 0 if kx is greater than or equals 1. I is 0.05, so nu is 1 over 1.05. K30 equals 0. And then the present value random variable z is 0 if K30 is greater than or equals 1. The probability of K30 equals 0, which is Q30, given as 0.004. And then we have P30, 0.996. The expected value of z is nu times Q30. And we get 0.003810. To get the variance, we need to get the expected value of z squared. And we get 0.003628. And then we have the actuarial notation. Make sure you are familiar with the notations. A discrete insurance, benefit of 1 payable at the end of the year of death. The policy is issued to an individual at age 30. This is a 1-year term insurance. The death benefit is only issued if the individual dies within the 1-year period. The variance, 0.0036. Okay, and then we reconsider the 1-year term insurance, and now the death benefit is B instead of 1. Let Z be the present value random variable for this insurance. By definition, Z is equals to B times nu if Kx is equals 0, if the individual dies within this 1-year period, or LZ is 0. All right, so this notation corresponds to a death benefit of 1, and therefore for the expected value of Z, this equals B times this big A notation, which is B times nu times Qx. And then the expected value of Z squared, we have B squared times nu squared Qx, and this is B squared times this big A notation, and we get the variance of Z. Okay, so let's take a look at another example. For a 1-year term insurance of 500, the death benefit is 500, issued to an individual at age 62. You're given that the death benefit is payable at the end of the year of death. Mortality follows the given life table on the left-hand side. The interest rate I equals 0.08. Z is the present value random variable for this insurance. Calculate the variance of Z. We have Z equals 500 times nu. K62 equals 0, or LZ is 0. I is 0.08. We have the present value factor, nu equals 1 over 1.08. And therefore, 500 times nu is 462.96. We need to get the probability. Q62 from the life table. Q62 is L62 minus L63, and then over L62, we have the two numbers here. Plug this in, and we get Q62. And then for K62 greater than or equals 1, this is simply 1 minus Q62, which is P62. We have the PMF. We can get the expected value of Z and the expected value of Z squared. And then we can get the variance. The expected value of Z and the expected value of Z squared, the standard notation, we can write this as 500 of this big A notation for the expected value of Z, and then the expected value of Z squared. We have this expression in terms of the big A notation. All right, so that's it for today's video. In the next video, we will cover a 2-year term insurance. Thank you, and see you in the next video.